All right, so we're still looking at integration by substitution, but with this example, this example also includes limits. We already know that whenever we use substitution, the method of integration by substitution, we're going to replace all the function in x with a function in u. So we're going to replace all the x values with u values. Now, when there's limits, you must also replace the x values, the x limits with u limits. All right. So here we have u is equal to 2x plus 1. I'm going to say when x is equal to 1, u is equal to 2 times 1 plus 1, which is 3. And when x is equal to 0, u would be equal to 2 times 0 plus 1, which is 1. So the limit x is equal to 1 is going to be replaced with u is equal to 3, and the limit x is equal to 0 is going to be replaced with u is equal to 1. All right, so we need to replace everything else. So we have u is equal to 2x plus 1. So u minus 1 is equal to 2x. Divide both sides by 2. And so we have x is equal to x is equal to u minus 1 over 2. All right. What else? We have u is equal to 2x plus 1. And so du by dx is equal to 2. Bring down the 2, carry up the dx, we get du over 2 is equal to dx. Alright. So now we should be ready to replace everything. So the integral, which is from 0 to 1, so the integral from 0 to 1 of x over 2x plus 1 raised to the third power dx could be written as the integral from 1 to 3 of x, but x is what? U minus 1 over 2 divided by 2x plus 1 to the third power. But 2x plus 1 is what? U. So this is u to the third power. And then now dx, I'm going to replace dx with du. Du over 2. So this is du over 2. So the 2 times 2 here is 4. So this becomes the integral from 1 to 3, 1 over 4 times the integral, and this is u minus 1 over u cubed du. Alright, so I could separate this a little into 1 over 4, the integral from 1 to 3 of u over u cubed minus 1 over u cubed du. Alright, so let's see how much of it we can get in here. If I do the integration, it's going to become 1 over 4. And this is, so I'm not ready for that one yet. 1 over 4 the integral of u to the minus 2. So if I divide u by u cubed, I'm going to get 1 over u squared, which is the same as saying u to the minus 2 minus u to the minus 3. So that's me applying my laws of indices, du. And when I integrate, I'm going to get 1 over 4. And this is going to become u to the minus 1. I'm going to increase the power by 1 and then divide by the new power, minus u to the minus 2, divide by minus 2. And again, we increase the power by 1 and then divide by the new power. So what we end up with is 1/4 minus 1 over u plus a negative divided by negative is a positive, 1 over 2 u squared plus c, the constant of integration. And we need to remember to put in our limits, which is 1 to 3, 1 to 3. All right. I think when you have limits, you should remember this. You don't need the constant of integration. All right. So this wasn't necessary. When you have limits, you can actually work out the values. You don't need the constant of integration. All right. So let's work out this the value here. Remember, I can go straight ahead and work it out because the values I have here are 1 and the 3. Those are u values. So now, so what I have is 1 over 4, and in bracket I have minus 1 over u plus 1 over 2u squared from 1 to 3. So this becomes 1 over 4 minus 1 over 3. So I'm replacing u with 3 plus 1 over 2 times 3 squared minus, replace u with 1, minus 1 over 1 plus 1 over 2 times 1 squared. This is 1 over 4 minus 1 over 3 plus 1 over 18. 3 squared is 9. 9 times 2 is 18 minus 1 plus 1 over 2 plus a half. All right, I'm just working down as we go. This now becomes 1 over 4 and 1 over 4. We have 18 minus 6 plus 1. All right, minus 6 minus minus 1 plus a half is minus a half. So now we have 1 over 4, and in bracket here we have minus 5 over 18 plus 1 over 2. So if I wanted to, I could do this again. 18 add minus 5 plus 9. 9 times 1 is 9. 1 over 4. So this is equal to now 1 over 4 times 4 over 18. And our final answer is 1 over 18. Final answer is 1 over 18. All right, let's see if we have time to do another one. All right, so let's hope that this is easy to do. Example 75. First of all, let's get the new limits. I have u is equal to sine x. So when x is equal to pi by 2, I have u is equal to the sine of pi by 2, which is equal to 1, when x is equal to 0, I have u is equal to the sine of 0, which is equal to 0. All right, so my new limits are 1 and 0. I have u is equal to sine x. So du by dx, differentiate sine to get cos, is cos x. Put this over 1, bring cos x down there, bring dx up here. We're going to have du over cos x is equal to dx. All right, and we do not have to worry about that cos x because it's going to cancel the cos x that is up here. All right, so now we're ready to write our integral in u. So the integral of the integral from 0 to pi by 2 of sine cube x cosine x dx could be written as the integral from 0 to 1 of u cube cos x, and replace dx with du over cos x. The cos x cancels, and so my integral becomes the integral from 0 to 1 of u to the third du. All right, so if I integrate that, I'm going to end up with, so this is equal to u to the fourth divided by 4, and my limits are from 0 to 1. When u is 1, I'm going to have 1 to the fourth power over 4 minus 0 to the fourth power over 4. So this is equal to 1 over 4. All right, so our final answer there is 1 over 4. 0 to the fourth power is 0. 0 divided by 4 is still 0. 1 to the fourth power is 1, so the answer is 1 over 4. All right.